Hello, in this lesson, I'm going to review the empirical rule and Chebyshev's rule. So first, the empirical rule, this is for a distribution that's roughly bell-shaped or symmetric. So the rule states that approximately 68% of data will be lie within one standard deviation of the mean. So what that means is if for population information, you can say 68% is lies within mu minus 1 sigma and mu plus 1 sigma. And then for sample, we'll say 68% of data will lie within x bar minus 1s and x bar plus 1s. Similarly, I can do the same thing for two standard deviation. So the rule states that approximately 95% of data will lie within two standard deviation of the mean. So that is, the 95% of data will lie within mu minus 2 sigma and mu plus 2 sigma for population information. And for sample information, I can say 95% of data will lie within x bar minus 2s and x bar plus 2s. And then for the third one, I will say approximately 99.7% of the data will lie within three standard deviation of the mean. That is, for population, we say 99.7% is between mu minus 3 sigma and mu plus 3 sigma. And for sample, we say 99.7% of data will lie within x bar minus 3s, x bar plus 3s. So the information can be summarized below. This is for population. Notice that this is population here. Population information. Well, if for a sample, only difference is that it's still shape, area, everything be the same. So the thing change will be the axis here. You can say mu here would have x bar for sample mean, mu for population mean, and for the right one standard deviation about the mean, I can say x bar plus s, 1 times s, which is just s. And second one will be x bar plus 2s and x bar plus 3s instead of sigma. So in place of mu, I write x bar. In place of sigma, I write s. Because s is the sample standard deviation, where sigma is population standard deviation. I can do that similarly for one standard deviation below the mean. I will do x bar minus 1 times s. The second two standard deviation below the mean, I will say x bar minus 2 times standard deviation of s. The two standard deviation, which is s. 3 standard deviation of the mean, I will say x bar minus 3 times s. Right? So that will be for a sample. So this part is for sample information is given. Know that the distribution has a bell shape. Then we use the Chebyshev rule. So this rule here works for any data, any type of distribution, right? It could be symmetric, it could be skewed left, skewed right. So this works for any data set. So it says the proportion of any set of data, again any set, lie within k standard deviation of the mean is always at least 1 minus 1 over k squared, where k is a positive number greater than 1. Okay, let's consider k 2 and 3. What does that mean? So for the empirical rule, we say 68% is within one standard deviation of the mean, right? And then which is what says right here with the graph right here. And then we say for two standard deviation of the mean, that will be 95% of the data within two standard deviation of the mean, and then within 3 standard deviation of the mean will be 99.7%. That will, and for the for 4 standard deviation of the mean, which is one below, that will be 99.99%. That will be for the empirical rule. Well, let's do the same thing for Chebyshev's rule. So this is k. Right. So for k equal to 1, it's just 0. So it doesn't give me much information here. And for k equal to 2, Well, let's calculate, see what happened when I have k equal to 2. So the k equal to 2 for, then I will have 1 minus 1 over k. So this, let me write it. This is first dot. So 1 over 1 minus 1 over k. K is 2, so 2 squared, which is 1 minus 1 over 4, which is 3 over 4. 3 over 4 is the same thing as 75%. 0.75 or 75%. Right. So I can say by the Chebyshev's rule, I can say at least 75% of data will be within 2 standard deviation of the mean. Right. So that will be 75%. Well, let's calculate for 3 standard deviation. And similarly, I can do the same thing. And for k equal to 3, we will do 1 over 1 minus 3 squared, which gives me approximately 0.89 or 89%. 89% approximately. So I say according to the rule, I will say at least 89% of the data will be within 3 standard deviation of the mean, according to Chebyshev's. I can do one more for 4, so 20% within the mean. Right. So notice that Chebyshev is always a little bit under. Now let's consider an example. Suppose we know that the mean cholesterol is 80 ml per dl with a standard deviation of 6 mg per dl. So find the following. When labeling your graphs, be sure to include the appropriate unit. Okay, so let's think about this is cholesterol. So if we can assume that cholesterol level are bell shaped, so we know it's bell shaped, meaning that I can use the empirical rule. What 2 cholesterol level can expect within 95% of all cholesterol level to fall? So the values on a curve. Okay, let's draw it. So I have my mean here. This is the middle one. This is the mean. Mean is 80, right? 80 mg per dl. And where the standard deviation, sigma, again, sigma is equal to 6 mg per dl. And this is my mu. Mu is equal to 80 mg per dl. Alright, so one standard deviation about the mean tells me I add one sigma, which is 80 plus 6, going to give me 86. Let me just do 86. And I can add 6, So I add 6, give me 92, add 6 again, give me 98. And so I want 95% of data within 2 standard deviation of the mean. So the mean is negative 2 sigma, positive 2 sigma. So meaning I want from this one all the way up here, that will be 95%. Well, I can say 95% of all cholesterols fall within 68 and 92. Right? So again, this is 2 standard deviation. So I say 95% is within 2 standard deviation of the mean. So we look for 2 below and 2 above. Okay, let's look at number 2. Number 2 says we can assume that the same condition. So we want a question asks me, if we assume that cholesterol level is still bell shape, would below what cholesterol level can we expect the lowest 2.5%? The lowest 2.5% is that is n, meaning that I want from here all the way here. That's the bottom 2.5%. So I want the lowest 2.5. Okay, so according to my previous marking, I'm doing the same thing. So on the bottom 2, so the middle is 80 here. From last time we said subtract 6, give me 74. Subtract 6 again, give me 68. Subtract 6 again, give me 62. So the bottom 2.5% is below my below which one here? Okay, let's highlight it on my graph. So this is the 3 standard deviation outside. So this from here to here, right? So between must be less than 68. The bottom of 2.5%. Again, you can even draw on here if it's easier for you to see. So note that this is my 80, even side by side. That will be my 74, and that will be my 68, right? So below 68. So let's answer the question. So I say we can expect that the lowest 2.5% cholesterol fall below 68, right? So we say, oh. And number 3, would it be unusual for a person to have a HDL cholesterol level less than 5 milligram for DL? Let's explain that. Okay, let's think about it. Unusual meaning that is less, the probability of happening is less than 5%. So 50 mgHL, if I would draw it, that would be, let's use the graph we did earlier, so it will be without the next one below. Right now, 3 standard deviation is 62, and 4 standard deviation. So 4 standard deviation is mu minus 4 sigma, that is 56. So even less than that, that's all the way out there. That's, that's under mu minus 4 sigma. So that's definitely less than 5%. So I say yes, it is unusual to see a person with a cholesterol level that's 50, because 50 mgHL, that will be mu minus 5 sigma. But 4 sigma is a 99.99% already. So mu minus 5 sigma, that's close to 0. The probability that happening is close to 0. So therefore, it will be unusual to see that. Okay. So it's always a good idea to write your answer in a complete sentence. I'll say it is unusual to see a cholesterol of someone that's 50 mg per DL, because we said that it's below 5 standard deviation of the mean. Question number 4. Okay, and the same condition holds. So we say if we assume the cholesterol is still bell-shaped, what percentage of cholesterol level can expect to fall between 68 and 98? Okay, 68 and 98 is from here all the way over here. Now notice that the lower bound here is 2 standard deviation below the mean. This is, let me write it out. This is mu minus 2 sigma, where 98 is mu plus 3 sigma. So according to the probability, we know 95% from 68 to 92 is 95%, and 95%, so will be 95% plus, again, let me to here, from here to here, let me draw it. From here to here is 95%, and then 92, and the third standard deviation here will be 2.35. So this is, from here, this is 2.35. So add them together to 2.35%. So that will gives me 97.35%, right? Let me box it right here. So I can answer the question. I would say 97.35% of the cholesterol level we can expect to fall between 68 mg and 98 mg per DL. Number 5, if we cannot assume that HDL cholesterol level is a bell shape, that means we cannot make that assumption. We don't know that it's bell shape. So cannot assume it's bell shape. What percentage of the cholesterol level can we expect to fall between 68 mg per DL and 92 mg per DL? Okay, draw 2 different versions of the non-bell shaped curve and approximate the values on the curve. Okay, so we know that we cannot expect to be bell shaped. So it could be any shape. So I want to find out what percentage between these two numbers here. So first, let's draw it. I cannot use the empirical rule, so I'm going to use the Chebyshev rule. So first, let's just figure out what the 2 numbers fall between. Well, from the previous problem, we kind of see that 68 is in the mu minus 2 sigma, where 92 is mu plus 2 sigma. From here, I can say k is equal to 2. Right? You can also draw a different way. You can also solve a different way to find your k. So I say 68 mu minus k sigma is going to give me 68. And we know, and mu plus k sigma is going to give me 92. I can use that to solve my k. We know mu is 80. So I will say 80 minus k times 6 equal to 68. I can plug in here as on the right hand side as well. 80 plus k times 6 give me 92. So for either equation, when I solve for k, you'll see that k equal to 2. Okay, I can draw a picture. So to represent that, okay, so I can say this is my muse. That's my 680. Right? So this is 2k, so that would be 68 here, and that is 2 standards about the mean, which is 92. And I want to find the percentage from here to here. What proportion from here? It's not bell shape, it could be, I think it might be, could be skewed, somewhat skewed, I think. That's not empirical rule. That's not symmetrical. It could be something like this. I want to find the area from here to here, right? The probability. So according to the rule, then I can say for k equal to 2, again, you can use either one of those to find your k here. So when k equal to 2, I will say 1 minus 1 over k squared, and that is equal to 1 minus 1 over 4. That will be 3 over 4. Or you can also say 0.75 or 75%. So we can expect at least 75% of the cholesterol going to fall between 68 and 92 mg per dl. Right? So that's how we will solve this problem. Thank you for watching the video. I'll see you next time.